Okay, so today we're back with some more calculus, and today we're going to be talking about how to prove or how we define a function as to be or to be continuous. So there's kind of three things that you need for a function to be continuous at a point. So first of all, I'm going to just say it. First of all, for example, we want to know that fx is continuous when x is equal to a. How about that? So first of all, fa must be defined. And for example, functions like, let's say, ln x minus 1, and then when x is equal to 1, this is just not continuous because it's just not defined. Okay, and then the second kind of thing that it needs is that the limit exists. So it first needs to be defined. Second of all, it needs to exist. The third of all, which is also kind of like the definition of continuity, is that lim fx is going to be equal to fa when x approaches a. So then it's going to be continuous at this point a. Okay, and so a very, very classic problem will ask you to, let's say, prove f is continuous at a if and only if lim h approaches 0, fa plus h is going to be equal to fa. Okay, so with this problem, it says that if and only if, so we need to actually prove it from both sides. So we're going to take f is continuous as a known assumption, and then we're going to try to prove that this is going to be true. And so if we have f is continuous, then we have the lim when x approaches a, fx is going to be equal to fa. And so when we have the definition is that f x minus fa is going to be less to epsilon, and then x minus a is going to be less than delta. And so we're going to say, since it's a function, so it doesn't really matter what's inside of the function, we can change it. Let's let x is going to be equal to a plus h. So then we have f a plus h minus f a is less than epsilon, and then x minus a is just going to be h is less than delta. This is going to be the fact that the limit when x approaches a, this was kind of wrong. So when h approaches 0, fa plus h is going to be equal to fa. So this is kind of like the definition. And then the other way around is also going to be the definition, but it's just going to be that you're going to change a plus h to x instead of changing the other way around. Okay, so we have that, and we also kind of want to something is that prove that let's say gx is continuous. I'll write that on negative infinity to 3, and then gx is going to be 2 3 minus x. And so we're going to take let's take n is within negative infinity to negative 3, and then notice that we're not getting into 3 yet. So the limit when x approaches n, 2 and then 3 minus x is going to be equal to 2 lim x goes to n, 3 minus x. So we're going to get 2, 3 minus n. And this is going to be equal to gn, so we know that is continuous on negative infinity to negative 3. And now we need to prove that when n is going to be equal to 3, we also need to prove that it's continuous. So we prove that a dot is continuous by taking its left limit, and then do this. And then this is going to be equal to, when it approaches 3 from the left side, this is going to be approaching 0, which is going to be equal to g3. So the limit is going to be equal to the fa, so it's just going to be continuous. So this gives you a hint that for every what do you call this? I forgot what you call this in English, but you need to treat this as a special case when it equals to 3. Yes, so if it's a range, yes. And then that's basically it for limits, I guess, to prove it's continuous. And there's also some properties, like, for example, basically all of the elementary functions you see are continuous, and you can use them as a fact. For example, all of the polynomial functions are continuous, and they let's say f and g are both continuous. So then f g, f plus g, f minus g, f g, g is not equal to 0, and then blah blah blah, they're all continuous. And for also like trig functions are all continuous, like polynomial functions are all continuous, and then everything you see is continuous. So a thing to look out for is like these, like for example, 1 when x is equal to when x is equal to 1, and then 2 when x is not equal to 1. This is just not continuous, because if you draw a coordinate plane, it kind of has a hole inside. So 1 is going to be there, for the rest it's just going to be 2. Just going to be a hole here, and so this is just not continuous. So continuous is basically there's no holes in the entire graph, and so all of the elementary functions do not have holes, and then therefore they are not they are continuous. Yes.